Hi, Year 10. I thought it might be useful for me to do a quick video for you guys explaining how Newton's laws of motion work and how they kind of work together, how you combine them together, because a lot of people find it quite difficult to understand them fully. So let's start with talking about why Newton's laws are important. Okay, so hopefully you guys did some of the work on resultant forces. Okay, now the basic idea of resultant forces is that you can add forces together. Okay, so let's say that's an object on the floor and there's two forces acting on the object. One is pushing to the left. Let's say it's 10 newtons, and there's one pushing to the right. Let's make this force a little bit bigger, and let's say that one is 20 newtons. Okay, now the idea of adding forces is so that you can calculate a total force. So if forces act in opposite directions, you subtract one from the other. So if I wanted to add these two forces together, I'd go 20 newtons minus 10 newtons equals 10 newtons. Okay, now force is a vector. Hopefully you know that vectors require a direction. So you have to give a direction to give a full answer. Now, because this one is bigger than that one, the resultant or the total force goes to the right. So the resultant force would look like this. It would be a force going that way, and it would be 10 newtons. I'll add an arrow here to show that my resultant force, I'll write in here, is equal to 10 newtons to the right. Okay, now that's for forces acting in opposite directions. You do get examples where they act in the same direction. So let's put two forces that act in the same direction. One there, one there. I'll make this one 15 newtons. Let's make this one 25 newtons. And you calculate it in a very similar way. Now I'm going to use a different color as well to help it make it a bit clearer. The resultant force this time is equal to this force plus this force. So we go 25 newtons plus 15 newtons equals 40 newtons. Now, just like last time, we also need to figure out what direction the resultant force acts in. Now, I'm going to use a slightly different color for the resultant force. Let's make it green. So the resultant force is 40 newtons and it's to the right. I'll add an arrow here to show that my resultant force that I calculate down here is equal to 40 newtons. Okay, so if they're acting the opposite direction, you subtract them. And if they're acting in the same direction, you add them. Okay, now you have to understand that bit before we can start to talk about Newton's laws, because Newton's laws are all about how forces change the motion of an object. Okay, so Newton's first law is about whether the forces acting on an object are balanced or unbalanced. Okay, so if forces acting on an object are balanced, it might look like this. So we've got the same object. We've got 20 newtons pushing it to the left, and we've got 20 newtons pushing it to the right. So these two forces balance out, and essentially they cancel. Because if I did the same calculation that we did before, resultant force is equal to 20 newtons. Because they're in the opposite direction, I minus 20 newtons equals 0 newtons. There's no resultant force. And what Newton's first law says is that if the forces acting on an object are balanced, okay, the object remains in its state of motion. Now that's a bit of a weird sentence. The object remains in its state of motion. All it means is whatever motion the object had before, it will keep doing it. So if this object is still, and then I push on one side with 20 newtons and I push on the other side with 20 newtons, it will stay still, it won't move. But if the object's already moving, let's say it was sliding down a hill, and then I'm pushing behind it with 20 newtons, but then something else is pushing back on it with 20 newtons, it will keep sliding down the hill, okay? I guess the other side of that rule is that if the forces aren't balanced, then the object will change its motion. That's really what Newton's second law is about, okay? But the real way that they write this, okay, and the way that you'll probably see it is an object remains in its state of motion unless acted upon by an unbalanced force. Okay, that's the format you see it in most of the time, and that's called Newton's first law. So it's all about whether the forces are balanced or not. If the forces are balanced, then the object will stay in the state of motion it's in. So it will either remain still or it will move at a constant speed. But if it's not, if the forces aren't balanced, then the object will accelerate. And that's where Newton's second law begins. So we'll look at Newton's second law. And Newton's second law is all about what happens when the forces are unbalanced. So let's go back to our simple box on the floor example. Now let's make the forces unbalanced. So let's say there's a 40 Newton force acting to the right, and there is a force acting to the left, but it's smaller. So we're going to make this force 15 newtons. The way we calculate the resultant force is the same as before. So resultant force equals 40 newtons minus 15 newtons, which gives us 25 newtons acting to the right. So the overall force, or the resultant force, pushes to the right. Now, because there's an overall force on the object, we know that the object is going to change its motion, okay? So unbalanced forces cause an object to accelerate. Now, this word's really important, accelerate. Acceleration is when an object changes its velocity. And this word velocity, it actually means more than one thing. So if you change your velocity, you can either change your speed or you can change your direction, or both, in fact, okay? And that's where Newton's second law comes in, because what Newton said was that the acceleration of the object, essentially it depends on two things, okay? So acceleration, and this bit most people understand quite clearly, it depends on two things. So it depends on the size of the resultant force, and it also depends on the mass of the object that's being accelerated, okay? Now, most people get the idea that if the force is bigger, so if this resultant force, and I'll draw our resultant force in because I haven't done that yet, okay? So my resultant force up here to the right is 25 newtons. If the force is bigger, then the object accelerates quicker. So it speeds up quicker. Okay, now most people get that. Similarly, if the mass of the object, so if the mass of this block is bigger, that means the acceleration is smaller. And again, most people understand that. The bigger the object you're trying to accelerate, the harder it is to accelerate it. And when you write that in maths, it looks like this. F equals m, which is the mass, times a, which is the acceleration. And this is Newton's second law. At least that's the form that they want you to remember it in. What it says is the force, or the resultant force that you calculate, so that was this one, is equal to the mass of the object, that's the mass of the block, times the acceleration of the block. So let's say that we've got F, which is 25 newtons. I'll put that here. So we've got 25 newtons. And we know that the mass of the block is, let's say it's 0.25 kilograms. Then I can calculate how quickly it will accelerate. That will tell me the acceleration. If you want to be able to do that, you just go 25 newtons divided by 0.25 is equal to your answer. I'll leave that to you to figure out. Okay, worth saying that acceleration is measured with a strange unit. It's meters per second squared. Okay, so that's Newton's second law. That's how it's meant to work. Okay, and then the last part of his laws of motion, and I think probably, I mean, it's, to me at least, it seems the most significant part, the most important part in terms of, you know, how the universe works, is about force pairs. So that's Newton's third law. I think it's easily the most difficult, most challenging to understand properly. Okay, and I would always write it like this. If object A exerts a force on object B, then object B exerts an equal and opposite force on object A. Now, I think that this is the most useful way to write down the law and to remember the law. Now, a lot of the time you might hear it written, you might hear it in different forms. People like to say to every action there is an equal and opposite reaction. But the issue with understanding this law is that most people forget that there are two different objects that you have to identify when you look for the pair of forces. And by remembering it like this, you're reminded that you have to find object A and object B. As soon as you find object A and object B, things are simplified. Okay. Now, I think I gave you some examples this morning. So I'll use those examples. Let's say we've got, I think there was a bookshelf and there was something on the bookshelf. I'm going to keep it simple. I'm just going to put a block on the bookshelf. Okay. Now, if we're looking for a Newton's pair of forces here, the first thing you've got to identify is what's object A and what's object B. Now, object A, let's just say that the block is object A, and let's say that the shelf is object B. So what it says is we've got object A exerting a force on object B. So what object A does is it pushes the shelf down. It pushes the shelf down with a force. I'm just going to call that force F1. I don't want to confuse anything too much by talking about how big it is. Okay, so we've got this force F1, which is the block pushing down on the shelf. what the law then says is object B exerts an equal and opposite force. Now the opposite means direction. So there must be another force that acts in the opposite direction, so up. But this force, instead of being on object B, the shelf, this force acts on object A, the block. So I'm going to draw this force in as well. It's equal in size, so I'll draw it about the same size, but opposite in direction. And there's my pair of forces. A force on the shelf acting down, and a force on the block acting up. Okay, I think there was another example in the questions I set this morning, so I'll look at that one. I think it was, there's a boat with a propeller, I hope. If I didn't do that, then please mention it in the comments below the video. And we've got the boat, nice simple boat, and it's got a propeller that's spinning. Okay, now the propeller spins and pushes the water. And so I'm going to identify my two objects first of all. I think it's probably simplest to put object A as the propeller. Okay, the propeller is that thing that spins at the back of the boat, pushes the water back. And then object B, and this is where people find it difficult to identify, object B is the water. The water is being pushed by the propeller. And so here it says object A, the propeller, exerts a force on object B, which is obviously the water. Okay, so now we've got to identify our two forces. We do the same thing that we did last time. So first of all, we look for this force. So object A exerts a force on object B. So object A is the propeller, and what it does is it pushes the water backwards. So I'll draw that in. I'm going to call this one F1. So the propeller pushes the water backwards. Then object B, the water, exerts an equal and opposite force on object A, the propeller. So the water pushes the propeller forwards. And I'll put that here and I'll call it F2. And that force, F2, is what pushes the boat forwards. That's the reason that spinning a propeller will push the boat forwards. The propeller pushes the water and the water pushes the propeller back. And this pair, these kind of pairs of forces exist with all forces in the universe. Okay, that's why I think that Newton's third law is the most important law when we think about, you know, significance in the universe, because actually these kinds of pairs of forces cause the vast majority of motion that, in fact, all motion that we have studied. Okay, so for instance, if you are walking along the floor, what you're doing really is you push backwards on the floor with your foot. Okay, so your foot pushes the floor and then the floor pushes your foot forwards, and that's why you move forwards. Okay, if you've ever been swimming, when you're in the water, what you do is you push backwards on the water with your hands and your feet, and the water pushes your hands and feet forwards, and that force pushes you forwards. Okay, same thing if you ride a bike. I know lots of you ride a bike. So as you turn the wheels on your bike, the wheels on your bike push the floor and they push backwards on the floor. Therefore, the floor pushes the wheels forwards and you go forwards. All of these are called Newton's pairs of forces. Okay. So look, that's a basic explanation of the three laws. I hope that some of that is useful to you guys. You know, please feel free to send me some comments or messages on Show My Homework, and I'll do my best to reply to them and respond to any comments. I'm going to set you some exam questions so that you guys can practice your understanding of some of this. And if you've got any problems, you know, again, just send them to me. I'm trying to do my best to work my way through any comments or feedbacks that I get from students. Okay. Good luck with your learning on this. Keep up the hard work.